So let me introduce the first speaker, and he has traveled along with his colleagues all the way from Brazil, and that's a pretty long flight to be with us here today. His name is Octavio. Can I get that? Okay, Octavio Paschoal, and he has a very interesting job title, Electronic Intelligence Agent. That's an interesting job title, Octavio. And his presentation is AI-tomation, Enhancing Control Systems with OPAS Innovations. So, Octavio, it's all yours for the first presentation in the first session. Thank you.
Good morning, everyone. In Brazil, normally, we are not having too much engineers in the companies, just analysts and agents, so I can consider myself a 777 agent, maybe. I was a little worried to be the first to present something here, but I forgot it will be a keynote before me. So now I'm very much more worried because of the brilliant presentation. Thank you. You brought us some insights that I can use here. So what's the title of this presentation? I just try to do some joke with AI and automation, right? I think you should realize that before. But what's the idea? In SMART, we are looking for OPAS as a technology, as a trained technology for automation. And first, we worked in order to develop systems, to develop something that we could bring to the market with some robustness and reliability. Okay, and after that, we got some success on it. Why not to bring a little bit of AI? So, including the slogan of this event, the winning the AI era, why not to bring? So here I try to context some insights, brainstorm some of the technologies, some of the features that I present here is still in the paper. Some are already being developed. So idea here is to bring AI, data, and OPAS together for you just to think about it and to talk later. So just a little bit about Nova Smart. So we're from Brazil, very close to here. So it's a very short trip to Singapore. Smart is a 51 years old company with partners here in this part of the world, in Singapore, in Malaysia, providing a lot of industrial process automation services, equipment, and so on. But what's the most important here? We are OPAF members since 2019. So we took a little bit to know about OPAF, but after that, we really entering the OPAF with a very clear goal to develop and to help with the open technologies development. And we have in a commercial line since 2023 that you have in our booth. After that, if you want to meet, you're going to be very pleasant to receive you there. So, going to the presentation, I'm going to talk about three things: about data, about AI on industry, and OPAS. And then I'm going to mix them all. So, about data. In the past, what's automation about? It's about automate things, right? To do things, to put things to do something automatically without minor human interference. But this is already over because not from today, but from some time ago, automation ends mostly to generate data. Data not only for the process, but for decision making. And one of the challenges that I have no hair anymore, but I'm actually not so old, but probably you most experienced guys may have this problem in the past, is how to standardize data, because in the beginning, all data from automation were in different format. So what first come? The first initiative, we are having now a data-driven times, which is every decision made by data, and how to standardize it. It comes with OPC, First, the classical OPC, now we have OPC way, and OPC way is being adopted as the mostly used communication pattern standard for industry for automation. So, what should be ideal? An architecture that allows the data to flow from where is generated to where is needed. So we talk about digitalization. One of the ideas is to make that ISA 95 pyramid a little bit different. So if the data is generated on the field, then this data must be used in enterprise network, why not to have some shortcut to do it? So if you generate some data in standardized format, it should be better. It should be easier. So, and having it, you can also avoid to have data silos, but have a unified data lake. So having a standardized data from scratch. And that's why I put OPAS here, because the idea of OPAS is using OPC way to generate the standardized data from the scratch. So, and what are the challenges with data? First, how to collect the data. So these are challenges, most of them are already accomplished, but how to collect from the plant using communication systems, how to process, which is the standardization of this data, how to get the pressure value, which is a physical value, and how to standardize this value in a way that can be understandable for machines, understandable for controllers or for other applications. How to protect, and this will come the cybersecurity. So when you have segregated networks, we talk about legacy systems, put just one firewall, maybe you don't have this flexibility to use the data where you want to. But having cybersecurity, you can protect your data. How to store, getting this data lake infrastructure in the cloud, on-premise, I don't know. Maybe you can use both. How to context, in this case, is how to understand the data for system integration. And how to use. And that's why we can put the artificial intelligence. About artificial intelligence in the industry, good. Why so hyped today? So I'm not entering these points, of course, because maybe all of them are not I'm not specialist on them, but production optimization, so thank you, Mr. Nair, because of your presentation, too. You went into all of these points. Production optimization or predictive maintenance improvement to know what's going to happen before it happens just because of data, and real-time decision-making. But when you talk about automation, we have an eternal war between cost, time, quality, safety, sustainability, security, etc. And why not to use AI to fight against this war, to get the more goals that's possible to achieve. And in industry, where you can find the AI is, of course, not limited to it, but one, as Copilot, so collaborative tools that can receive data and then can deliver some suggestions, or agents that can perform automations, automatos decision, can perform some automatos tasks. So we're going to talk about it in the terms of the OPAS. Good? And one of the points that we can see a lot of, or not a lot, but some of applications having it, automation and native language. So PLC configuration being generated by natural language, or report generation, or machine integration. So is something that is present now. It's something that is happening now. This is just a small timeline that showed how the AI entering the automation. First, manual systems, and then basic automation, and then centralized operation. You can have here the digital communication protocols in DCS, but centralizing all the information in a central point and database in SCADA systems. And then we have the transition to use the AI in 3 different steps. First, assisted operation with predictive AI. So maintenance is using this every time. It's It's impossible to deny it, because many companies are betting on this kind of applications. Then prescriptive, when the system gonna having the information what's gonna happen, the whole system will deliver information on how to treat it. And after that, which I think is a little more complicated, to have use the deep AI for intelligent operation. So the plant gonna operate by itself without the use of operators. So it's like I have seen a slide that compares cars with automation. So we have now the autonomous operation with human together, having the monitoring. But in movies, you have seen already intelligent operation. The guy just entered the car, say where you're going, when to go, and then just leave the car to go. So gonna be something like this. But of course, for cars, we need to preserve our lives in automation systems, in plants, not only lives, but also the assets. Good, about Opus. Have you seen this diagram before? Who have seen this before? Some, but not all of them. This is good. This is the Opus architecture. So we call gold and blue diagram. For me, it was already always yellow and blue diagram, but I think I listened to Mr. Ravi in Bangalore talk about gold and blue diagram. That shows what is legacy, what is Opus. And the idea is to interconnect everything, every automation application in a standard-based system using DCNs. So the idea here is just to show to you, we can have the conversation later, show you practically in our system, but this is what we have for Opus, a decoupling between hardware and software applications running anywhere you want in any node that can process any software. And let's mix them all. This is an architecture that comes from that gold and blue diagram. And this shows to you some applications here, some components. We have I/O, we have the DCNs, we have the orchestrator, and we have configuration tools. And having this architecture, which is a more practical one, how can AI approach Opus solution? And here I will show to you 3 points that you can use AI, that you have this brainstorm where AI can be used. First, Gen AI assisted configuration. So since there are some companies investing in PLC configuration through AI, why not do the same for Opus? Second, AI-based system management using the orchestrator, which was one of the most important components of the Opus architecture. And thirdly, AI field data analysis. We will do this all the time, but why not to do it with standardized data that come from Opus, which is the Opus signal. So first, for the configuration, in the tool Nova CSB, which is the system configuration, AI uses its copilot. So in short term, we could have this. How can I create a simple PID control loop? And the AI shall bring us insight that generate it. Not directly, but at least some insights for new engineers, for people that are starting with the technology, or that are starting with this configuration too. Second, again, how to parameterize PID function blocks and give insights to us to parameterize a block for a PID, for AI, for etc. But in long term, why not to have it? Giving the PNID and having the information. We have this image upload and ChatGPT. We can do this for analysis. Why not to do it? Using the learning of the system, of this copilot in Opus technology. This is an application that is running now. It's on beginning, but we have some, we are starting to develop, so it's not only brainstorm, it's something that we're creating now. So it's mostly easier to show in short term, not in a long time. Second, the orchestrator. which is the big brother, is the eyes that see everything. The orchestrator using system management applications as Redfish. It can see what are my resources, my DCNs, memory, and also to help to deploy the applications. So what you have now for an orchestrator, it comes from IT. So we already have IT tools using for scaling, balancing, deployment, and management, which you can say about the Kubernetes, one of the technologies used for it. And what this Kubernetes can do in this way of scaling, balancing. So it checks the load, peak provision and scaling before, and triggers actions before it happens. So it's already there, using or not AI is not the matter on this case, in the case application. But how can we use AI in this case, having already some application that can use or not AI? Opus is known to be a multi-vendor architecture. So the idea is that you have multi-vendor being used not only in hardware, but also in software. And when you deploy an application on DCN, you need to orchestrate it. So the idea is to do it as much automated than possible, not do it manually. And for each runtime, for each vendor using each container, you have like a playbook. You go to Ansible, you go to other orchestration tools, you can have these playbooks or receipts. Each vendor must have yours. So why not to use AI to help integrator to create several bench of receipts or playbooks to help them to put as more vendor applications as possible together. And last but not least, the AI field analysis. So what Opus defines? When you go to the Opus standard, it doesn't define what application shall do, but define the interface that your application must have for hardware and software. So one of these interface what we call Opus Signal. Opus Signal is a OPC way based information module with some information inside, not all of them. So having this information from the scratch generated by the system, from the scratch, from the DCN IO gateways, or even for the IO platforms, why not to have an application using AI to do this? A kind of analysis of the data. So one example, on behavior process control, the data going directly to an Opus Signal data lake, and then an AI-based application with the Opus Signal interface, and then correcting the process. Okay, and just to finalize, at the end of the day, what end users' pain point can be healed here? First, using AI gen assisted configuration. Less time to create strategies. So, because you have this this help, this support from AI. A more complex strategies being learned according to time. You start with a simple control loop, and then you can increase the complexity of your strategy. Cleaner configurations with only the parameters that are necessary for your configuration, not all of parameters that maybe you can configure without need. And more complete documentation, because you put inputs on the system, and this system can generate cleaner documentation for you. Second, orchestrator, AI-based system management. This is the optimization of multi-vendor receipt. So this can help the role of integrators that may use this more. And AI field data analysis, having a unified Opus Signal data lake, and having these Opus interfaces directly with these AI tools. So this is just insights. Again, this part of the Copilot for configuration is already running on the beginning, but it's already running. We're training some AI system with Opus inputs to learn about the system. So we hope that it will take not so much time to have something to show you, like a test bed or demonstrator. But this is what we recognize to be achieved in the Opus architecture. Okay, guys, thank you. I don't know if I put all my time here, but was a pleasure to talk with you. Later can talk better during the event. Okay, thank you, guys.